another server if I can live. If you want the beer opener, by the way, it's just over there. Cool.
Yeah, let's just go live now.
Are we live now?
And I'll check.
Hello, hello. Can you hear me? We're going to be going live soon.
And I'll see you on my...
Hey guys, here for the meetup? Wonderful. Sign in for us quickly and we're about to start. Food will be here in about 10 minutes and sorry guys, if you can hear this online, no food for you.
I think it's working.
Are we live? Alrighty. If I can grab everyone's attention real quick, grab a drink, find a seat. Hopefully everybody can grab a seat. We've got a big crowd today and really thank you for coming. The community really has grown in the short time we've revived this. We started off with about maybe 7, 8 people rocking up in about 2022. Grew to about 15 or so. 15 is a nice comfortable number. You can have a bigger chat. Our last was 20 and we thought we really hit it off, but this is a nice sizable crowd. So big thank you to all for rocking up and to probably the 3 people online. That's the best part. So first off, hi, we'll go through some introductions. My name is Bojan Zivic. I'm a principal consultant at Mantel Group, but beyond that, I'm also a AWS community builder, just like this gentleman right here, and also an AWS ambassador. So if you had to check my blood type, it probably wouldn't be AB or 0, it'd probably be AWS. And today we're going to be looking at the Serverless Meetup. What I'll be going through before we obviously get to that point will be a bit about what serverless things happened at Recap.
Yeah, well, we also have a few extra updates, but I'm going to talk about ECS versus EC2 versus Lambda comparison, which seems to be a big topic. We've seen within our clients a bunch of different implementations. It's always a hot topic to debate, like should I use Lambda, should I use ECS, etc.
Yep.
Yeah, so that's going to be my focus.
So what we'll also be going, and I think we can kind of kickstart things now, the serverless groups have got together, and this is a shout out to Pete, Nick, Matt, and the rest of the organizers of this event. There's an event starting called Serverless Days ANZ. This is the second time they're running it. Initially it was in Melbourne. Now they've actually spread it across to Sydney and Auckland. Now unfortunately it's not in Brisbane yet. We are kind of poking and prodding, saying, hey, there's a community here. And if they don't believe us, I'll be taking a selfie later, so they can have a good idea how many people we have. And as part of that, for those that are lucky enough to travel and head to Sydney at some point, or Auckland for that matter, today's the last day for early bird tickets. So if you can try to expense it, maybe expense the flight as well through company, or if you're interested in going, scan the QR and come join a bunch of other serverless people as well. There'll be a fair few AWS heroes there as well at the event speaking. There's a hint, hint. We've also got a couple community builders as well as a couple people from Adobe and Seek. So this is for software people, engineers, and really anyone who wants to learn more about serverless. And if you want to talk. So this isn't just about watch a bunch of other people. If you've worked on serverless, you have any good ideas, if you've had any experiences, good, bad, whatever they may be, or if you have any sort of input or thoughts, and you want to speak at the conference, whether it be in New Zealand or in Sydney, the call for papers is still out. So hopefully that QR code isn't too blurry. Scan away or come see me afterwards and I'll give you the link. And now, AWS reInvent. Hands up who knows what that is. All right, so for those that haven't, reInvent is basically AWS's way to say every year, here's the cool new big things coming out. And here's the things you should use 12 months from now. And what they've done this year is, you're probably all guessing, they're focused heavily on AI. And the one thing they jumped on straight away, and this is going to be relevant for us to an extent as well, this is why I'm kind of shouting it out here, is that they brought out Amazon Q, which is their competitor to effectively ChatGPT, but for the software engineers here and the platform people here, and apologies about the lack of air conditioning, it plugs into everything. So if you haven't, why this is great is because if you're on your journey to serverless or you're trying to find reasons to describe to people how to do things, I can describe to you a million different things on how to actually work on it, right? but you're still going to have to dig through the documentation. Treat Amazon Q as your way to filter through documentation real quick. Treat App Composer as your tool in, and then treat that YAML template as potential prod. You can get creative as well. You can change that YAML template to CDK using CDK migrate after changing it to CloudFormation, and then you can make it more proddy. And if you're using Terraform, bad luck. Jokes aside, they're going to give love to other infrastructure as codes as they go along, but they need to, treat their kids first before they treat others. Anyone here who wants to try to use any of their AI stuff and have used CDK? They've released a Git repo for, I'd say, 90% of all the AI services they have at the moment. So feel free to jump on, scan that QR code, or head to that GitHub link there to play with what they have with AI at the moment. I think it's all in TypeScript, so if you don't like JavaScript, apologies in advance. At least it's
I think it totally was around like.
It's on? Hello, welcome. All right, everybody, grab a slice, grab a drink. We're going to finish up with all the wonderful stuff from Recap, and we'll continue from there. As a heads up for those listening online, probably all three of you, we've got a fan today. Our aircon's being wonderfully painful. Grab a pizza, grab a beer, or alcoholic ginger beer for that matter. And yeah, we'll finish up shortly because the interesting talk is not mine, it's Illia's afterwards. Cool. Whoop. Awesome. All right, by the way, the only reason why I've got my phone out is I'm just checking the video. It's not vain to look at yourself online, all right? Alrighty. So I left you with step functions. And the reason why I left you with step functions is they decided, you know what? We created a great tool, but we forgot a key feature. Redrive. So step functions are a way for you to orchestrate a bunch of services inside of AWS. But one that we've seen more and more of is orchestrating serverless services, as well as using something from step functions called state machines. Why do I have to make the business logic for my app when I can just incorporate something called a state machine that does it for me? For example, write message to Dynamo, pull something out of SQS, and so on and so forth. Step functions have these state machines that can do it for you. But the redrive to recover from failures did not exist. And what that meant for those that had to rerun things, it could mean that starting from the chain from the top. Now it meant that you can start from a lower level. So if you look at business execution side, maybe it's step 20 you just rerun from instead of step 1. So save time and money, which, and I've mentioned this many times, but I'll mention it again. If you look at the wonderful case of what happened with Amazon Prime, and one of the reasons why their serverless implementation cost them squillions of dollars was because they used step functions wrong. Serverless is great when done right. But anyway, they've also implemented a HTTP endpoint integration. What that means is that if I need to reach out to HTTP APIs all around the world, I don't need to have my Lambda function be the one to do that. I can pass that logic to a state machine if I'm not correct. I'm pretty sure I'm correct. I'm getting nods. Yes, I remember correctly. It was only 4 months ago I was there. And then the one that was a given, of course, it's not an AWS reinvent with AI if they don't put an AI integration into it. And then finally, test states. So if you need to do some testing inside your API with step functions, you can do that too. CloudWatch got a bunch of love. It means that basically you can now use some better logic to search your CloudWatch logs as well as your CloudWatch metrics to get more historical and better data. You want to know where something broke as quick as possible. And the one that we all like to talk about again is security. All right, we all have wonderful code that we keep secure with code scanning and things like Dependabot to tell us that dependencies are late, as well as if we're building and pushing containers to Lambda, yeah, you can scan the container. But what happens after it's running in the real world? You're not really scanning your Lambda code after it's already been deployed, right? Most of the time it's like, oh, no, it's fine. Last pipeline said I had no CVEs, right? Well, a bad actor can come in and change a Lambda function, and quickly that changes. Through Inspector now, you can actually do code scanning and generative AI. So it can pick up things like data leaks. It can pick up weak encryption, which if you can do MTLS, great. If you can't, try to do it. It makes life a little bit more secure. And it is actually creating actionable responses in Security Hub. We have a question.
Not necessarily a question, but there's a new function coming to EC2 that does runtime scanning in EC2 using GuardDuty.
You heard that first? So there's another one coming out. So if you're in EC2 land or if you're running EKS and Cube, you actually have GuardDuty that does something very similar to Inspector, which is awesome. And IAM Access Analyzer. We chucked this one in here for a reason, because if you're doing serverless inside of AWS, you're dealing with IAM. And you want to know exactly where things are working and how they're working and who has access to them. Well, if you're part of a big organization or you like to have multiple accounts for resourcing, IAM Access Analyzer can go through and tell you why certain things have too much access, where they have access, and what you should really be doing. Gives you some brief recommendations on why you should be doing list privilege. just be using release privilege. And this one's fun. Who knows what their free tier is? Nobody. Put your hand down. That's a lie. Well, they finally told us how we can use it. They've created an API. So for the software devs and those around us like me who know how to Google and use Code Whisperer, we can now figure out what our actual free tier looks like in our accounts. So if we really want to abuse the system, I mean, thank AWS for their wonderful work and make sure we don't have to pay too much. We can use these to actually do proper monthly usage limits for our free stuff. And I'm sure things like AWS Nuke at one stage or another are going to have that integration as well, because that would be awesome. And my favorite. The only time I'm going to say an AWS announcement that is S3 is my favorite by far. And I'm actually going to kill it after this, because nothing is as fun as this. One zone Express, or Express one zone from S3. One of the biggest issues with S3, and usually people don't say there's issues, has been latency. Because if I create an app in AWS and I have an S3 bucket that I'm using as blob storage, right? I have to wait to pull, wait for the API to execute, and there's the latency that gets built up from that. Whether it be 20, 30, 40, 50, 150 milliseconds, that's Lambda execution time that's wasted in wait. When you have Express one zone, you give up a little bit of redundancy for the ability to have sub 1 millisecond latency response times. You basically have the same latency as you would have, frankly, better than, on the equivalent level of, say, a SAN. NAS storage, bringing up terms from the data center world. And what that means is if you're running a data lake, if you're running a serverless application, if you're using S3 for any sort of storage, hell, if you're using it to load your Parquet files if you're a developer or data person, and then utilizing something like, I think it was either DuckDB or CockroachDB to do memory executions at 1/10 of a second, this is going to improve things a lot quicker. If you have these apps now, I really highly suggest you use it with a caveat of, your stuff's not going to be as reliable as the ones before, because what they do to get this magic, they put it as physically as close as possible inside of the data racks to where you are. So it's beyond edge location. I think it's, I can't remember the name, but let's just call it beyond edge location for argument's sake. There's an API to do it. And then EFS. Look, EFS, I'm going to go quickly over. If you have to use Lambda, if you have to use serverless inside of AWS, if you're on Cube, condolences again, but most of us are, come on. EFS is going to be a backbone for long-term storage if it's not going to be S3, and it just got a whole lot quicker. Reads are up to 2,500, and write IOPS are at 50,000. In the bad old days, to get that at this scale would cost you a lot. They made Aurora limitless as well for writes, means that you can actually have a giant write if you can actually afford it that scans out beyond the standard limits, which means that it will do native vertical scaling at the cost of arm and a leg and probably most of your kidney, so just be cautious. And then Elastic Cache Serverless, kind of like the same level we spoke about with OpenSearch Serverless. It gives you the ability to have a lower level of compute until you need more, where it can then scale up as need be. And finally, this is a fun one. Party Rock. If you wanted to try AI without having to read through about 1 million different things of documentation, scan this. It's AWS's free tool to actually trial making your own LLMs using an LLM. Behind the scenes, it's using Bedrock. So I've done things like basically said, create a, Create a bot for me that speaks like Gandalf does. So every time I gave it anything, it gave me a poem. I've done another one where it's basically been like, write to me in lyrics of Lil Wayne with every question that I write. So it's super powerful. And it's, it's a bit of fun. And that's me. Done with service announcements. On to the man of the hour, the great local Brisbaneite himself, Illia, to talk about Lambda ECS versus EC2. Thanks, everyone.
Well, that was insightful, I think. Just give me 1 sec. All right, so this is what I'm going to talk about. Myself, my name is Illia. I think I might actually share some of those slide decks on Meetup page, so you can grab all those links and QR codes. But more than happy for you to reach out to me on LinkedIn. So I'm a principal consultant with an AWS capability. I used to be a full stack engineer. I started with .NET, C#. It's been like old dark days. Now it's TypeScript, no offense, Python, TypeScript, JavaScript. Cloud engineering. My background actually wasn't too much in IT. It was mainly corporate finance and law. but at some point my life made a massive turn. And I'm also a mentor at River City Labs. I'm not sure if you guys know. It's a startup hub here in Brisbane. So if you're ever going to run startup, you can always book a session with myself as a mentor. I'm also a mentor for Queensland Government. They have a nice initiative called Mentoring for Growth. So again, if you know anyone who's running like a small or medium business and they need a bit of advice on technical side, that's me. So how many of you know what is serverless? I mean, you came to the Serverless Meetup, but can you raise your hands like if you used serverless before? All right, so if you came to this meetup not understanding what is serverless, this is a slide for you. So we were looking at some traditional deployments initially when people were used to just buy some bare metal, put it under the desks and run some servers. And you had full control over everything. So you could use your own software, you could use your own like pretty much anything, security, antiviruses, networking, and it's been up to you to manage. The next step was to start using infrastructure services, which is basically virtual machines managed by someone else. So you, instead of keeping all your servers under your desk, you started using data centers, and you started actually using virtual machines with the introduction of hypervisors, etc. So in this case, you still had full control over everything apart from physical devices. So you knew that your device is not going to be destroyed or not going to be stolen from your under the desk location. The next logical step forward was to use some platform services such as ECS or RDS that allow you to use cloud providers or maybe other data centers as a service, mainly cloud providers. In this case, you don't care about software installation maintenance. So if you're using like RDS instance, for example, you don't need to install SQL Server. It comes with RDS instance. Similarly, you can use ECS, but you still need to think about how you're going to scale, how you're going to plan your capacity, how you're going to make all the data service integrations. Well, the cloud native approach of cloud native that in this case, AWS is going to manage a lot of stuff for you. So basically, just need to write the code. And Lambda is an environment. It's basically an environment where you can run snippets of code in a reasonably fast manner. So you can ask, but why do we need to even compare? So I think I work for a consultancy, Mantel group, if you didn't notice. We have this question all the time, like why we should use serverless over EC2 or ECS. So I decided to run that experiment basically to build some evidence so we can support the viability of serverless architectures in AWS. And we also wanted to collect some empirical data so we can come to our clients and say, look, we compared ECS versus EC2 versus Lambda. That's our finding. Is it good for your use case or not? I also found that there are like tons of articles on the internet. This idea wasn't like super fresh. You can see a lot of articles on the internet, but I think they don't really have a lot of concrete examples, and they have a lot of like technical theoretical claims. So you will see a table where you have EC2, ECS, Lambdas, and they just say that compare cost and maybe availability, etc. Something like that. So that was another article from like quite a popular case study used within consultancy from Deloitte. You can see that where they say, okay, if you're using like serverless, then your time to deploy will be 8 days. If you're using not serverless, it's 25 days. Great, right? Makes sense. Or this one from McKinsey, where you can say, okay, your time to market, if you're using function as a service, which is translated to serverless, it's daily, or maybe multiple times a day you run releases, compared to like monthly on infrastructure as a service, which is something like EC2. And you can say that your productivity is maybe 40% higher than your traditional deployment baseline. So maybe many of you have seen those examples. But when I see any of that evidence from those articles, I've been always thinking, but how do you calculate this? How can you actually say that your productivity is like 40% higher? Quite often, they just have like a questionnaire. They ask IT managers, etc. But then you don't really compare apples to apples, in my opinion, because maybe your performance improvements are a result of completely other things, like infrastructure upgrades. Maybe you did some code refactoring. Maybe you just provided some more efficient hardware because you've been running your application, let's say, on like 10 years old box sitting under your desk. Maybe you improved runtimes. So as a part of migration, maybe you jumped a version of, I don't know, like Node.js from like 10 to 20. Maybe you don't have right people, or you hired right people. So your productivity not increased because you moved to serverless, but it's increased because you hired right talent, which is difficult to measure, right? Like you cannot say, if I join a company, how much value, or maybe how less value I'm going to bring to that company. So, and I think that's also the point. Like probably most companies, they will never migrate to serverless if they're completely happy with their existing solution. So you usually migrate things that are currently broken or not efficient, and then you compare. If everything is working as expected, you're probably not going to invest lots of money. Or you're building brand new applications, but if you're building brand new applications, you don't have a baseline to compare to. So that was my intention why I decided to compare. So I wanted to abstract all the code logic. So we're only looking at the workload. I'm going to, in my test, I'm going just to deploy the same code to Lambda, ECS, and EC2 and see how it works. And the use case, fairly simple. I have a happy user here who's trying to access API. API is sending a request to some sort of backend. That's how most things in IT world work, and probably like 101 into software development. And then you can insert some records, or maybe you can drop some files into some sort of object storage. So fairly typical scenario. I think a lot of use cases at a very like simplified terms fall under this. When we translate it into AWS world, we're using an API gateway. In my case, I've been using HTTP API. We want to keep all our compute within private network, and we drop in files into S3 bucket or DynamoDB. So we're using like VPC gateways for that. And the only thing that is going to be different, it's whether we to ECS or Lambda. That was my original idea. And I tell you that I'm a Python dev, kind of. So that's my beautiful code. Basically 10 lines of code where I'm just using AWS SDK. I'm grabbing S3 bucket name, DynamoDB name, which is my database and object storage. And I'm just generating some sort of random random file name. I'm dropping a file into S3 bucket. I'm dropping, and I'm putting a record into that DynamoDB. So that's pretty much everything my API is doing. I created one more endpoint, just a health check, because that's how you need to implement things for, not for Lambdas, but for EC2 and ECS. And my architecture that I'm really proud of, that basically looks like that. So you have HTTP API that invoking Lambdas that exist in the private subnets, and those Lambdas just drop in files to DynamoDB and S3 bucket. If we go with Fargate, yeah, and by the way, for my deployment, I'm just using CDK. So just CDK and putting that beautiful Python code in there. Thanks. ECS scenario, kind of similar, but because it's ECS, we need to use a few more extra things. So that's where complexity is using. We need to use auto-scaling ECS again, like we have Fargate tasks deployed to different private subnets. We have application load balancer, and we have to use VPC link to connect with HTTP API. And for ECS, because it's ECS, I'm just putting that Python script into a Docker container. EC2, it's quite similar. Instead of Docker, I'm just using some bash scripts, basically just to start fast API server. And quite similar. I deploy in EC2 instances into multiple private subnets with auto-scaling group configured. It also goes via application load balancer VPC link. And yeah, and I was thinking, well, let's now test, but if we want to really test it properly, we need to smash with lots of requests. So there is a tool called K6. I'm not sure, has anyone heard about K6? Yep, nice. Bojan knows. So K6, it's basically a testing automation tool used for load testing, where you can spin up multiple virtual users on your server, and you can create like different scenarios how you want to test or run some load testing. So in my case, I was just simulating load testing with quite a lot of requests per second, where at the beginning we have like a minor traffic, maybe like 40, 50 requests per second. Let's think of, I don't know, news agency, 9news.com, then something happens. Well, I don't know what can happen, but another prime minister resigned. So you have a sudden traffic spike. Can your system cope with that? Then maybe, I don't know, something else is happening, like, or maybe some of the dependency services crash, and you don't have that traffic anymore. And then you have rampant traffic increase to quite a solid numbers here. I'm talking about like 500 requests per second, 600 requests per second. To put it into some sort of real-world example, that's a traffic that some larger banks expect on Boxing Day when they're handling transactions at a peak level. So, and then, yeah, we also want to simulate a sudden traffic drop because we want to, and slight load decrease at the end. Because we know that usually all those traffic changes are not happening like over like very short period of time, I wanted to run this test for 6 hours and see how my solution is behaving. Well, a really quick demo just to show how it's been set up. And I have actually a link to the GitHub repo. So if you want to replicate it, hopefully you can just run a few commands and it's gonna, it should work. Maybe not, but it should. I'm just deploying all my, again, like it's a bit of like 101 into CDK world. CDK is infrastructure as code tool. So all my deployments, I never go to the console, never do anything in the console manually. So I'm just deploying, I've been running Python. I found Python CDK a little bit less advanced than JavaScript, but you can see that we're deploying EC2 stack, ECS stack, and my Lambda stack. And also I'm deploying my K6 tool into a separate stack just to make sure that they're not fighting for the same resources. The deployment for Lambda is basically, it's super simple if you're deploying on CDK. So I'm creating S3 bucket, DynamoDB table, so just using SDK constructs out of the box. You create a Python function where I'm setting like 512 megabytes, some timeouts, some environment variables, and I'm also creating HTTP API, Lambda integration, etc. So if I'm deploying EC2 instance, I'm going quite similar things, creating bucket, creating DynamoDB table, creating auto-scaling group. That's where a little bit complexity kicks in. Then I need to copy some of my bash scripts. Then I need to execute those scripts, etc. But for example, the bash script in my EC2 instance, it basically looks like I'm installing some dependencies and I'm importing my Python with requirements.txt. So I'm installing all this stuff and starting the server. So it's fairly basic stuff. For ECS, I'm also having a Docker file. And once it's all deployed, we do have, so that's an AWS account. Let me see if I can make it a little bit larger. Yeah, so I have my 5 stacks deployed. So shared infrastructure, that's my VPC. I didn't bother creating like multiple VPCs because in most cases you have a VPC already on the client. And what I'm going to do, at each of those deployments, if I'll go to the outputs, you will see that I have some sort of HTTP URL. So that's the URL that I can make a call. It's just a GET call that is going to trigger that Lambda or whatever function I created. And the K6 bit is, it does look like that. So I'm just saying I want to run a ramping increase to 100 virtual users for 15 minutes, then drop to 40 users for 15 minutes, then increase to 90 users for 15 minutes, etc. So that's my plan for 6 hours. execution. And I did a bit of extra steps. So on my K6, I implemented CloudWatch streaming. So all my logs from K6, including response times, errors, everything else, is going to be streamed into CloudWatch metrics. And I'm using those CloudWatch metrics to display them on very nice dashboard, because we don't want to look at metrics, at logs. We want to look at metrics. And by the way, CloudWatch dashboards you can also configure as a code. It's nice like JSON template. What you can do, you can just drag and drop a lot of things in the console, then you export it and put it into the code. Just try to keep everything in the code. I think it's just a good practice and also makes a lot of sense. So what I'm going to do now, I'm going to go to my EC2 instance where I have my K6. So you can see here that I have my 2 EC2 instances here. They're actually running that Python code. They load balanced, so we have 2 instances running. And this is my EC2 box where I just want to run my quick test. So I'm going to use Session Manager just to SSH basically to that box. And I have my nice command to run K6. And K6 is going to execute all these. Yeah, you see that it's initializing like 3,000 users, virtual users, and then it's trying to run those iterations. So you can see how many requests are getting made each second, and this is how many requests being completed. So it's already like a few thousand requests, which is pretty amazing. And I just want to show you quickly. On the CloudWatch, I created a dashboard. In this dashboard, I can see my Lambda performance, my ECS performance, my EC2 performance next to each other. But also I'm grabbing some additional stats like, let's make it a little bit smaller, average response time, max response time. Max response time is important because everyone cares about Lambda cold start. So we want to know what it is. Iterations total, number of 200 requests, number of 500 requests, just trying to understand are there any errors. And in here, when I run this, it generates execution ID, because obviously when I implemented the first time, I ran a few tests. So now I can go in, and we all live in UTC time. So I pick the latest, so pretty much my latest invocation. So you can see that those requests, they started coming in. So we can see that here we have 162 requests being processed. We'll see the ECS performance. We see how many ECS tasks being spin up, because we scale, and we want to test the scaling. And I don't limit that scaling. So if we need 50 EC2 instances, it's going to scale to 50 EC2 instances. And we're checking Lambda performance, how many concurrent Lambdas running. Once test is running for a little bit longer, we will start seeing those numbers coming in as well. So we can wait for 6 hours and come back, or I can just show you while it's still running, and we can get back to that if anyone is interested, but I'll probably skip it for now. The results. So I just spin it up basically using out of the box settings, and that's what I've seen. So you remember my K6 graph that I was showing here? So that's how it looks like in my Excel spreadsheet. That's how it looks like in my CloudWatch, which is pretty similar. And you can see Lambda is blue here. And you can see that Lambda worked pretty well. But ECS and EC2, they were on par at the beginning, and then their performance started deteriorating quite a lot. So it's not supposed to be like that, right? Because it's supposed to scale. So I took a look at it a bit closer, and I was like, well, I see that, for example, my ECS scales out from 2 to 3 tasks here. Then at here, when we have that sudden spike, it hits 100% CPU utilization. So basically, your instance cannot cope with the requests anymore. Then it realizes 5 minutes later, or 3 minutes later, and okay, we need to scale now to 5 instances. It scales up to 5 instances, but it's not even close to what it's supposed to be. Then by the time it recognizes that it needs to scale again, your traffic dropped, and then it's slowly ramping up, and you can see that it's trying to kind of do it properly, but it fails, and at some point it didn't even scale anymore. And the reason for that was that when I look at the ECS performance, I can see, so on the right you see the number of tasks that have been spun up. It worked really well at the very beginning with the lower usage, and then it started hitting 100% CPU utilization, and it never really recovered from that. Why it didn't recover? It didn't recover because I've been using also average CPU utilization here. And I've been using average CPU utilization to scale. One task was at 100% capacity, another task was at 20% capacity, so it never scales. But you're getting like all requests basically failing from that first task. So I spent quite a lot of time working on EC2, ECS. I was like, oh, let's scale like super aggressively. As soon as your CPU hits 40%, spin up another, I don't know, like 5, 10 tasks, whatever. Then it kind of worked. So I managed to achieve what I wanted to achieve, apart from this bit, because, yeah, it's still not as good as Lambdas. And the main reason for that, I think, is that gap. So any auto-scaling, and I think Bojan is going to now to probably confront me with EKS, that we need to use EKS for that stuff. But any of those auto-scaling models, they always reactive. So they react to what happened to your workload. After you hit 100%, if you're using just default settings on a CloudWatch, it typically waits for 3 signals coming that your CPU is above certain threshold. And those signals also, if you're using like advanced, how's it called, or detailed monitoring, they run only like every minute. So you're still going to be like 3 minutes behind the actual demand. And yeah, you can see that it's impacting both ECS as well as EC2. You always hit CPUs and scaling is happening a little bit later. And because you're also scaling at steps, it's not managing that traffic. Well, Lambda performance, so that's the number of Lambdas running. It basically replicated what I needed. Sometimes AWS is trying to pre-provision extra Lambdas to handle your spikes. But overall, it basically looked similar to what I would expect. So I sent a lot of API calls. 50 million, close to 50 million in total. And yeah, by the way, my test is still running, right? So if I go there, you'll see that, yeah, so that's what I've been running. Like at the moment, in my test, it's like close to 50,000 requests, but remember, it needs to run for 6 hours. But what I've got was something like that. So all 3 solutions processed roughly the same number of requests. Why there is a bit of difference? Because when you run K6, you send a request, you wait for response. If you wait for response longer, it means you process less requests at the end. But ECS and EC2 started actually throwing some errors. Lambda never failed. Almost 5 million requests, not a single error. That's pretty cool. Those errors, I think they come in because of that scaling activity that sometimes might impact the behavior. Average response time, well, Lambda wasn't the fastest, too. But on a large scale of things, I think it's fairly comparable. 45 milliseconds versus 56 milliseconds. I think it depends how you're going to word it. If you're going to word it like 20% increase, yes, it's a lot. If you word it like 10 milliseconds increase, no one notices. And average response time, you can see that actually Lambdas is been pretty much on par with EC2. So my conclusion, those two are quite comparable. Max response time, you remember a cold start that everyone complains about? Lambda is much more predictable. You know there is a cold start. You never know how ECS and EC2 are going to behave when they hit CPU or memory utilization limits. So I'm not saying that Lambda cold start isn't an issue. I think people overthink the importance of cold starts. It really depends on your use case, but if you have a fairly stable traffic, don't worry about cold starts too much. And the costs, surprisingly, compute is cheap. We always thought that storage is cheap, compute is expensive. Well, 90% of my costs, I run the test on on a few occasions. And 90% of costs were S3, DynamoDB, API gateway, not compute. When I've been running for 1 hour, for 6 hours, the cost that for Lambda that was like $1. For ECS and EC2, I had to combine multiple services because sometimes you look at ECS only or EC2, especially in EC2 scenario. Like EC2 is only 2.39, but you also know that you cannot deploy without load balancer. You cannot deploy without, I mean, you can, but you're not supposed to deploy without a lot of other services, including CloudWatch here, because you need to have that detailed monitoring, and you pay extra for the detailed monitoring. Otherwise, your scaling time, I think default one is it like 5 minutes metrics? So you don't want to wait for like 10, 15 minutes to scale up or down. So in total, if you just combine the compute costs, well, Lambda also looks a lot more attractive. And the main reason for that is because whenever you use either ECS or EC2, you always need to over-provision. You always need to deploy more than you need. And more aggressively you scale, more money you're going to spend on the wasted, basically, compute resources. So, conclusion, it excels, I think, in everything, especially under spiky loads. I still believe that if your traffic is like super stable, probably it's less important what deployment model you choose. If you do experience those spikes, it seems like Lambda is a lot more solid. We also had missed requests. Again, how important is it for your business to miss any requests? Well, that's probably my personal thing. That's why I didn't touch EKS. In order for me to run that Lambda with CDK, I think CDK was roughly 50 lines of code. My Python script is 10 lines of code. So it took me how many days? Yeah, maybe even less than that. But with ECS and EC2, look, it kind of looks okay, it's supposed to work, then you deploy, then it doesn't scale, you need to go back, you need to investigate, you need to spend a lot of time, enable detailed monitoring, then again, it doesn't scale, so you need to go and change the metrics that you're using to scale. Lots of things that can go wrong. And then you also need to make sure that if you're using EC2, you're always upgrading your runtime, you're always running some maintenance. Yeah. I think fine-tuning scaling policies, in my opinion, takes a lot of time. And it's not about just writing the code. And the cost management too. I felt like Lambdas are not bad. Obviously, you can improve it. Like you can use reserved instances, you can have some saving plans, you can actually get a lot of maybe credits from AWS if you want to. But again, like this was a very out-of-the-box comparison where I just wanted to check what is available there without need to negotiate with AWS reps, etc. And yeah, that's basically unutilized capacity of ECS and EC2. It's always going to hit. I have a blog on this topic, so whatever I just said, instead of coming here, you could just read it in the blog, but we wanted you to come. So, but if you want to read it again, that's a link, that's a QR code. I also don't make a secret of my code base. Again, GitHub link. If you want to experiment yourself, feel free just to create some branches. Maybe there will be something useful for your particular use case. If you know that you need to use, for example, pandas on Python, how is it going to impact you? So you don't need to think about K6 and other stuff. Just pull this code, add the code you want. And the very final one. Become a Mantelorian if you want to. If you want to do stuff like I did. If you want to work on the projects like the one I've been working on, you should come and join Mantel Group. We have Petra at the back. Talk to her. We're always looking for great talents. Yeah, and thanks Mantel Group for sponsoring this. Yeah, that's it. Thanks for coming.
Alrighty, thanks everyone. Illia, do you have time for questions?
If there are any questions, I just want to stop this because otherwise it will be
This is, ladies and gentlemen, how you burn a lot of money in AWS.
yeah, like for nothing.
Yeah, exactly.
171 API calls.
Thought Lambdas were cheap.
Hey. Alrighty. Does anybody have any questions for Illia?
And what I really like about this stuff, you can run it as many times as you like, and you will get the same results, roughly, after 6 hours.
So the exact opposite of insanity. Nice.
Yeah, which is the reason for it.
Exactly. Any questions regarding any of the releases at Recap or reInvent rather? Awesome. Well, look, we've got about 20 minutes, 22 minutes or so before they kick us out. If you'd like to chat about Mandalorian, we've got a lot of jobs open at the moment. Software, GCP, cloud. Feel free to scan or chat to Petra at the back, person waving there. And don't forget to grab the last couple of pizzas. Thanks for coming. Have a good one. Oh, and one quickly, I got to get a selfie with everybody. I know it's cringy, but deal with it.
It's like a Taylor Swift.
All right, 3, 2, 1. Beautiful. Alrighty, thanks for joining.